Let's take a look at the first example. Say you're a production engineer at Norman's fourth largest cracker factory, and you're considering two different layouts for the factory floor, layout A and layout B. You can't go through the effort of changing the physical layout of the factory floor, so you develop a discrete event simulation model for each layout, and then you compare the resulting throughput measured in pallets of cracker boxes, simulated for an 8-hour shift. You simulate 8-day shifts 30 times over for both layouts. The mean throughput of layout A is 1,284.4 pallets with a standard deviation of 369.4. And the mean throughput of layout B is 1,548.3 pallets with a standard deviation of 259.7. What is a 99% confidence interval that captures the difference in mean throughput performances for these two layouts? Okay, so we simulated these results. We could collect whatever sample size we wanted to with the simulation because we weren't actually having to go out and witness this out in nature. We were just doing a simulation. So we simulated 30 different throughput values for layout A, which we're calling population 1, okay, just to keep the same notation as always. We'll just call this N1, okay? And it had a sample throughput average in terms of number of pallets of cracker boxes as that was 1,284.4 pallets. And the standard deviation here was 369.4. Okay, for layout B, we simulated the same. We're going to call it population 2. We collected 30 samples of that. And the sample average for layout B was 1548.3. And there was a standard deviation of 259.7. Okay? So now we got to go through this crazy degrees of freedom calculation. I'm not looking forward to it. I know you aren't either, but let's do it together. Okay? So we have S1 squared over N1 plus S2 squared over N2, that's a squared. All of that quantity squared. Okay? In the denominator, we have S1 squared over N1, all of that squared, all over N1 minus 1. And to that, we add S2 squared over N2, quantity squared, all over N2 minus 1. Okay? Now let's rewrite this all over again with the numbers in place. Okay, if we do that, let's do that down here. We've got 369.4 squared over 30 plus 259.7 squared over 30, all of that squared. Then in the denominator, we have 369.4 squared all over 30, that squared, all over 30 minus 1. To that, we're going to add 259.7 squared over 30, all of that squared. And we're going to divide that by 30 minus 1. Okay? Nasty, but we got to do it, and let's not make any mistakes. And we get a value of 52.04. Okay, 52.04, that's not an integer. We have to have an integer value for the degrees of freedom. So our degrees of freedom, we're going to round down. Okay, let's even call this an approximation. We'll call it 52. Okay, we'll call that 52. Okay, so we want a 99% confidence interval. Okay, so 99% confidence implies that alpha is 0.01. Okay, so we need to go find a value of t associated with 52 degrees of freedom and alpha over 2, or 0.005, in each tail. Okay, we probably aren't going to have that in our textbook or in our t-table. We can use Excel to find that, and if we do that, we get 2.674. Okay, 2.674. So now let's implement our confidence interval. Y1 bar minus Y2 bar. Okay, that's our point estimate. We're going to add to it and subtract from it a margin of error. That margin of error is T, 52 degrees of freedom, 0.005 in each tail, times S1 squared over N1 plus S2 squared over N2. Okay? So this, all we got to do now is just enter in these numbers. We've got those. 1284.4 minus 1548.3 plus and minus 2.674 times the square root of S1 squared, 369.4 squared over 30, plus this standard deviation, 259.7 squared over 30. Okay? So this is our confidence interval, right? Just got to work that out. And if we do, we get this. Negative 484.4 pallets up to negative 43.5 pallets. Okay, this is our confidence interval for the difference in throughputs between layout A and layout B. Okay, so what does that say? With 99% confidence, I think the true difference in the throughputs between layout A and layout B is between negative 484.4 and negative 43.5 pallets per day. Okay? Another way to say that, since both of these are negative, that layout B is greater than that of A to the tune of 43.5 to 484.4 pallets per day, okay, with 99% confidence.